In this video, we are going to talk about the derivative of an exponential function. So let's say we are given y is equal to a raised to u, and u is a function of x. And from this function, y is equal to a raised to u, we want to solve for the derivative of y with respect to x. So to do that, first we are going to take the logarithms on both sides. So therefore, we would have here the, let's take the natural logarithm. So we'll have ln y is equal to the ln of a raised to u. Now, the ln, or the natural logarithm of a raised to u, can also be written as u times ln a. Ln a will now be a constant. So if we will get now the derivative of this function, then we will have derivative of y with respect to u over y is equal to u times ln a. So we have to apply ln a, the derivative of a product there, and then derivative of u with respect to u. Okay, so if we will simplify, we will now arrive at derivative of y with respect to u, or we'll sub 1 over y times derivative of y with respect to u is equal to, so this will now be 1, ln a. Okay, so derivative of y with respect to u, derivative of y with respect to u is equal to y times ln a. But remember, we want to solve for the derivative of y with respect to x. So we will again apply chain rule. And remember that by chain rule, the derivative of y with respect to x is equal to the derivative of y with respect to u times derivative of u with respect to x. So derivative of y with respect to x is equal to derivative of y with respect to u. We already have that. And that is equal to y times ln a. Y times ln a times derivative of u with respect to x. Okay, so but what is y? Y is equal to a raised to u. So finally, the derivative of y with respect to x is equal to a raised to u times ln a times derivative of u with respect to x. So that is our formula for the derivative of a raised to u. Okay, so again, if we want to get the derivative of a raised to u, then this is the formula that you will use. So applying this concept, we can also apply that concept in getting the derivative of e raised to u. Okay, so if we will get the derivative of e raised to u, and here we have solved for the derivative of a raised to u, so therefore applying that, the derivative of e raised to u would be equal to, so let's just follow the pattern. We have a raised to u, e raised to u times ln a, so we have ln of e times derivative of u with respect to x. But we all know that ln e is equal to 1. So therefore, the derivative of e raised to u is simply equal to e raised to u times derivative of u with respect to x. So again, the derivative of a raised to u would be equal to a raised to u times ln of a times derivative of u with respect to x. And those are the two formulas. Okay, two formulas that we would use in this topic. So let's go to our example problems. So find the first derivative. So number 1, we have y is equal to 10 raised to cosine 2x. So here we should identify that a is equal to 10 and u is equal to cosine 2x. Okay, so if we will apply the formula of the derivative of a raised to u, then therefore y prime would be equal to a raised to u, so we have 10, which is just the given, no? And then ln, the natural logarithm of a, in this case 10, and then the derivative of ru, which is cosine 2x. So let's continue. Y prime would now be equal to 10 raised to cosine 2x times ln 10 times the derivative of cosine is simply equal to sine, but we have here 2x, so therefore our derivative is sine 2x, 2 sine 2x, and the derivative of cosine, by the way, is negative sine, so therefore we have negative 10 cosine 2x times ln n times 2 sine 2x. So we just have to rearrange everything so that it would look presentable. So let's have negative 2 times 10 raised to cosine 2x times ln 10 times sine 2x. Okay, that is our final answer. So problem number 2, we have y is equal to e raised to negative x squared. So again, let's just identify that ru is equal to x squared. So the formula that we will use is simply equal to e raised to u times the derivative of u. So let's just write first e raised to u, that is our e raised to u, and then the derivative of ru, which is negative x squared. So what is the derivative of negative x squared? It is simply equal to negative 2x. Okay, so if we will write that down, we'll have negative 2x times e raised to negative x squared. And that would be our final answer. Okay, so problem number 3. So problem number 3, we have y is equal to x raised to negative 2 times e raised to negative 2x. Okay, so for this problem, we will not apply the derivative of our exponential function first, but instead we will apply the derivative of a product. So we'll have y prime is equal to x raised to negative 2 times the derivative with respect to x of e raised to negative 2x plus e raised to negative 2x, then derivative of our x raised to negative 2 with respect to x. Okay, so we have x raised to negative 2 times derivative of e raised to 2x, so we have e raised to 2x, then derivative of our u here, which is 2x. So we'll just have negative 2. And then we have e raised to negative 2x, then derivative of our x raised to negative 2, so that would be negative 2x raised to negative 3. Okay, so next step is just look for common factors. So the common factors are x raised to negative 2, and we also have e raised to negative 2x. Okay, so we'll have negative 2. 2 is also a common factor, by the way. So let me add negative 2. Okay, so let me just erase this. So we'll have negative 2 as one of our factors. So negative 2x raised to negative 2, then e raised to negative 2x. Okay, so here all of these terms are factored, so we'll simply have 1 there, and then we'll have here e is factored out, and then negative 2 is factored out. So the only term left would be x raised to negative 1. Okay, so we'll just simplify this. We'll have negative 2, and then 1 plus 1 over x. And then here we'll have x squared e raised to 2x. So again, we can still simplify this further as x plus 1 over x squared e raised to 2x, and finally our y prime would be equal to, so we'll have negative 2 times x plus 1. And then the x here will go to the denominator, and this will now become x cubed times e raised to 2x. And that would now be our final answer. So we'll go to our next problem, problem number 4. So we have y is equal to e raised to 2t plus e raised to negative 2t all over e raised to 2t minus e raised to negative 2t. So here we will apply the derivative of a quotient, and let's recall that the derivative of u over v is simply equal to v times derivative of u minus u times derivative of v all over v squared. Okay, so our u here is the numerator, our v is the denominator. Okay, so first denominator e raised to 2t minus e raised to negative 2t, then derivative of our numerator. So we can simply already mentally solve for this. So we have e raised to 2t, so our u is 2t, so therefore the derivative of that is 2, and then we'll write the e raised to u. Okay, and then next e raised to negative 2t, so the derivative there is negative 2, then we have e raised to negative 2t. Okay, so again the derivative of e raised to u is e raised to u times the derivative of u. Okay, so that's the reason for that. Then minus the numerator, so we'll have e raised to 2t plus e raised to negative 2t. Let's get the derivative of our denominator. So we'll have 2 e raised to negative e raised to 2t, positive 2t, this one. And then this one, because this is negative 2t and the derivative of negative 2t is negative 2, and this is negative, so we'll have positive there as well. So we'll have positive 2t e raised to negative 2t. Okay, and then let's square the denominator. Okay, so let's just simplify that. So first, let's just imagine if we factor out 2 here and then 2 here. So we'll have 2 as a common factor. Then we'll have e raised to 2t minus e raised to negative 2t. We factored out 2 from there, so we'll have e raised to 2t minus e raised to negative 2t. Okay, and then here we also factored out 2, which is already here. So we'll have e raised to 2t plus e raised to negative 2t times e raised to 2t plus 2e raised to, oh, there's no more 2, plus e raised to negative 2t. Okay, so 2 was factored out and it was already here. So divided by e raised to 2t minus e raised to negative 2t squared. Okay, so here we can see that we have like terms here and also like terms here. Okay, so that's basically the square of a binomial, and if we will get the square of a binomial, we'll have, so for the first term here, we'll have e raised to 4t, okay, e raised to 4t, and then if you multiply these two together, okay, then you will produce 1 because of the exponent, and what would be left is simply 2. So first we'll have e raised to 4t and then minus 2. Okay, then we will square this one, so the square of that one is plus e raised to negative 4t. Okay, then minus, so we'll do the same thing here. Okay, so we'll have e raised to 4t as our first term, Then what will now be our middle term? So our middle term is, again, if we multiply this and e raised to 2t times e raised to negative 2t and then multiply by 2, the only term left would be simply 2. So plus 2. And then for the last term, we'll have the square of this one. So we'll have e raised to negative 4t. Okay. Then the square of the denominator, e raised to, let me just copy, e raised to 2t minus e raised to negative 2t squared. Okay. So what can we simplify, Here, because this is e raised to 4t, and if we will distribute the negative here, then that will now be, those two terms will be cancelled out. Okay. And then we'll have negative 2 here, and then another negative 2 there. So that will now be negative 4 if you add them together. Now we have e raised to negative 40 here, and then if we distribute the negative sign here, we'll have negative e raised to negative 40. So it will also be cancelled out. So the term or the quantity that's just left is simply negative 4. So let's just copy the denominator. So finally, y prime is equal to negative 8 e raised to 2t minus e raised to negative 2t squared. And that will now be our final answer. Okay. So last problem for our video involves a implicit function. And the implicit function is x squared e raised to negative y plus y squared e raised to negative x is equal to 1. So let's get the first derivative, or the y prime. So we have here x squared. Then let's get the derivative of e raised to negative y, of course with respect to x, plus e raised to negative y, then derivative of times the derivative of x squared with respect to x. So we applied the derivative of a product. We'll also apply the same for the second term. We have y squared, derivative of our e raised to negative x, and then plus e raised to negative x, derivative of y squared with respect to x is equal to the derivative of 1 with respect to x. So we know that the derivative of 1 is 0 because that is a constant. So next step, we have x squared, derivative of e raised to negative y would be e raised to negative y. Then derivative of negative y is negative y prime plus e raised to negative y times 2x, the derivative of x squared, plus y squared. Then we'll have here negative e raised to negative x plus e raised to negative x times 2y prime is equal to 0. So let's group the first term and the last term because they both have y primes. So we have x squared times e raised to negative y. Let's write y prime first. Negative y prime times x squared times e raised to negative y plus 2y prime times e raised to negative x. So that is equal to, let's put this first, it will become positive. We have y squared times e raised to negative x minus 2x e raised to negative y. Okay, so we'll factor out y prime. So we have 2y times e raised to negative x, then minus x squared e raised to negative y is equal to y squared e raised to negative x minus 2x e raised to negative y. And then finally, we'll have y prime is equal to y squared e raised to negative x minus 2x e raised to negative y over 2y e raised to negative x minus x squared e raised to negative y. And that would be our final answer. Okay, so that's it for the video. Thank you for watching.